to start off, work or power is defined as the rate at which work is done. The equation for power is shown here. P equals W over delta T. And the SI unit for power is the watt. The P stands for power, the W stands for work, and delta T stands for change in time. So for my story equation, I calculated how much power I generated while skipping over the distance of 100 feet. To start off, we needed to find velocity. Velocity equation is d over t, and 100 feet, which was the distance I skipped, converts to 30.48 meters. So plug 30.48 for d, and then the time it took to skip that distance was 6.74 seconds, and that ended up to equal 4.522 meters per second for our velocity. Next, we found acceleration, where we plugged in our previously found velocity. So it's change of velocity over time. So our final velocity was 4.522 minus our initial velocity, which was 0, over our time 6.74 equals 0.671 meters second squared for our acceleration. And then plug that into our force equation. Force equals mass times acceleration. My mass was 74.84 kilograms times our acceleration, which is 0.671 meters per second squared. That turned out to be 50.217 newtons. And then you plug the 50.217 newtons into our work equation. Work equals force times change of distance, so 50.217 times 30.48 equals 1,530.614 joules. Then finally, you take that the number we got for work and plug that into our power equation, which is P equals W over delta T. So our work again was 1,530.614 joules, and that's divided by our time, which was 6.74 seconds, and that turned out to be 227.094 watts. So that's how many watts I generated while skipping the distance of 100 feet in 6.74 seconds.